about transcription. Transcription is the process of converting DNA into RNA. To begin the process, first the ta-ta box in the promoter signals for the creation of the mRNA by helping RNA polymerase figure out where to bind to the strand. RNA polymerase is a transcription factor, which is an enzyme involved in the process of converting DNA into RNA. The RNA polymerase binds to the ta-ta box, which is a DNA sequence that indicates where the beginning of DNA copying can occur. So, on our model, this strand is the mRNA. This is our mRNA strand. This is the ta-ta box here. And since the promoter contains the ta-ta box is the green and yellow, and the promoter is yellow, so it's all together. And the mRNA strand starts here at the 5' cap, and the RNA polymerase is the orange. This is the coding strand, and this is the template strand. And the RNA polymerase is rezipping the DNA here and unzipping it here. Once they are bound together, the RNA polymerase begins to unzip the double helix and copy the DNA sequence by adding RNA nucleotides starting at the 5' cap. Like I said, this is the 5' cap. Then rezipping the helix behind it and elongating mRNA or messenger strand RNA, where the RNA nucleotides are bonded to DNA, is called the DNA hybrid complex. So this is the DNA hybrid complex right here, because these are DNA nucleotides bonded to RNA nucleotides. So on the board, I'm going to show elongation. So here we have it starting at the promoter, but here we're going to say this is the promoter. Ta-ta/promoter. And so if our strand of ta-ta and promoter are all the way back here, this means our RNA polymerase is right here. And so it already rezips here, and it's unzipping here. And our strand is elongated off. So this is our 5', and then more RNA nucleotides are added on to the 3' end until the mRNA reaches the termination site at the 3' end, where it's signaled to stop the process of copying DNA. The mRNA, which has been created, is referred to as pre-mRNA because it contains both exons and introns. Exons are coding regions and introns are non-coding regions. Therefore, after the signal of termination, RNA splicing begins. During RNA splicing, introns or the intervening segments get cut out. However, the materials in introns stay in the nucleus and get recycled, so its nitrogen bases can be reused in DNA and RNA. So, let's say these are the introns, and these are the exons. So the introns get cut out, and the exons get put all together, and the introns are recycled. A little So there you have it, that's transcription. Please keep watching to find out about translation.
Kick off your Sunday shoes, please, Louise, pull me off of my...
Hi, I'm Usha, and I'm here to talk about translation. Translation is the process of converting mRNA from the language of nucleotides to the language of proteins and amino acids. After an mRNA goes through transcription, it exits the nucleus and it enters the ribosome. A ribosome is made up of mRNA, of proteins, and rRNA. rRNA contains no genetic information, however, it contains 3 binding sites, the E site, and the P site, and the A site. And they allow mRNA to interact with tRNA. tRNA is also known as transfer RNA, and it has the purpose of bringing amino acids and anticodons into the ribosome to be paired with the correct codon. And a codon is a set of 3 nitrogenous bases. So an mRNA goes through the ribosome, which reads each set of codons and matches it with the correct tRNA anticodon. So the mRNA continues to slide through the ribosome at the A site, the P site, and the E site. The A site is also known as the acceptor site, and it binds to mRNA and contains the tRNA anticodon on one end and an amino acid on the other side. The P site is also known as the peptidal site, and it binds to tRNA and is where the growing polypeptide chain stays, because before a tRNA in the P site moves to the E site, it gives its polypeptide chain to the tRNA in the A site. And finally, the E site is known as the exit site, and it's located on the end of a ribosome. So before a tRNA can get to the E site, as I previously stated, it gives its polypeptide chain to the tRNA on the A site, and then it comes to the E site without a polypeptide chain and exits the ribosome. So basically, as a new anticodon enters the ribosome, the anticodon that is in the P site gives its polypeptide chain to the A site, and then it moves on to the E site, where then it can leave the ribosome while a new tRNA enters the ribosome. And then this process continues until the anticodons UAG, UAA, UGA, or UGG are paired with the correct codons in the mRNA strand because they signal termination.
Everybody cut.
I'm Isha, and back again to talk about the effect of mutation, specifically in transcription. In transcription, a mutation would be caused by the incorrect copying of a DNA strand where a single base is changed, resulting in an incorrect base in the mRNA. So for example, in our DNA template strand, if this stands for thymine, an incorrect copying, it copied it as cytosine, which would result in a single base being changed in the mRNA, which would cause further problems in translation. A mutation of this sort can cause a variety of genetic disorders, such as cystic fibrosis, sickle cell anemia, Tay-Sachs disease, color blindness, and many others. Keep watching to find the effect of mutation in translation.
Haley here again, but now I'm talking about mutation, specifically in translation. In translation, a mutation would most likely occur because of an incorrect RNA nucleotides added during transcription. Thanks a lot, transcription. A mutation would cause incorrect proteins on a polypeptide chain, so it would not function correctly and wouldn't perform its job. Also, if an incorrect codon codes for stop, then there's a possibility of death in the womb due to a lack of necessary and specific proteins. To demonstrate that point, as we know from translation, UAG codes for termination or stop. So, if this is the anticodon, this is the codon. So if our codon is AUG, but it's supposed to be AUC, then the anticodon would be UAG, and it will code for stop. So it would stop the polypeptide chain, and the protein would not be complete. Therefore, would most likely kill the organism it was in. Where am I with Isha and Haley?
You can fly if you only cut